Hello students, welcome to our chemistry lesson. I'm Mr. Pascal Omosa. Today I want to teach you the Solvey process of sodium carbonate. Sodium carbonate is a very important chemical because it has uses, and we use it in the manufacture of glass and soap. So for us to form sodium carbonate, for these purposes, we need substances to use, which are called raw materials. And the raw materials for this process, I'm going to write them here. The raw materials for the Solvey process. The first raw material is concentrated sodium chloride, which is also called brine. Brine is concentrated sodium chloride. The second raw material that we need in this process is limestone. Limestone is another name for calcium carbonate. Calcium carbonate. The last raw material for this process is ammonia. Ammonia gas. Ammonia's chemical symbol is that. I'm going to break down this process into chambers. The first chamber of this process, we are going to feed the first two raw materials, that is ammonia, NH3, and sodium chloride, which is concentrated. In this chamber, we are going to form a mixture of ammonia and sodium chloride, and the mixture is usually called ammoniated brine. Ammoniated brine. So this tower is called ammoniation. Ammoniation tower or ammoniating tower. This mixture of ammonia and brine are taken to chamber number 2. And there is a reaction that is going to be taken to this to happen in this chamber. But there is also something that is added to this chamber. This chamber is called the carbonator. It's called the carbonator. And the reason why it is called the carbonator is that the gas that is brought to this chamber is carbon 2 oxide. And how do we get this carbon 2 oxide? It's because in the upper chamber here, this is where we feed the third raw material, which is limestone. And the reaction that happens in this chamber is heating. And now I'm going to write the equation. Calcium carbonate, which is limestone, is heated to form calcium oxide plus carbon 4 oxide gas. So this carbon 4 oxide is brought to the carbonator. But from this chamber, the calcium hydroxide formed is taken to another chamber, the following chamber here. I'm going to draw a chamber like this. Into this chamber, water is added. Water is added, and the addition of water to calcium oxide is called slaking. So this chamber is called the slaker. The equation in this chamber is calcium oxide reacts with water that is added to this chamber to form calcium hydroxide, which will be taken to the next chamber. So this chamber here, I will write calcium hydroxide to another chamber here, which you are going to know what will happen to there afterwards. In this carbonator, 2 equations take place in the carbonator. So I want to write the equations here. The first equation is ammonia reacts with carbon 4 oxide, and some water is also added to this chamber. So the first equation is ammonia, NH3, reacted with carbon 4 oxide from the from this chamber here, carbon 4 oxide, plus water. Water is also added here to the carbonator, plus water. And this one is going to give us ammonium hydrogen carbonate, which is an aqueous solution. So I write AQ. The ammonium hydrogen carbonate formed in the second equation, ammonium hydrogen carbonate, is reacted with the brine now. The brine, which is a raw material, sodium chloride. This one is aqueous, and this one is also an aqueous solution. So the reaction between ammonium hydrogen carbonate and sodium chloride forms two products. The first product formed is ammonium chloride, and the second product formed here is ammonium hydrogen, not ammonia but sodium hydrogen carbonate. These two products, one of them is an aqueous solution, so ammonium chloride is an aqueous solution, but the second one is a solid. If we have a mixture of an aqueous solution and a solid, we are going to separate this mixture by filtration. That means from the carbonator, we are taking these two products to another chamber, and I am going to call this chamber the filter, to a filter. In this filter, during filtration, we have a residue and a filtrate. Sodium hydrogen carbonate is going to be obtained as the residue, while ammonium chloride is going to be obtained as the aqueous solution. Therefore, from this filter, I am going to have two products. One of the products goes to this chamber here that I'm going to say which chamber is that, but the next product is taken to a chamber here, and this chamber where we are going to heat, if we heat, we cannot heat an aqueous solution, but we will heat sodium hydrogen carbonate. So after filtration, sodium hydrogen carbonate here is going to come to this chamber where heating will take place, while ammonium chloride is going to be taken to this chamber. So where am I going? I'm going to show you the equation at this chamber, and in this chamber we are going to do heating. That means we are going to decompose sodium hydrogen carbonate. So the decomposition reaction for sodium hydrogen carbonate, I write here, sodium hydrogen carbonate is heated, and after heating, this is where we are going to obtain our sodium carbonate for our process that we want to make whatever we want. Water is also formed in this reaction, and also a colorless gas, carbon 4 oxide, is formed. So if I write the state symbols, sodium carbonate, water is a liquid, and carbon 4 oxide is a gas. This carbon 4 oxide obtained in this chamber is required in the carbonator. So what we are going to do here, we are going to recycle it. So carbon 4 oxide is not released into the environment, but it is recycled. So in questions we will be asked, name the gas that is recycled in the Solvey process. So that gas is carbon 4 oxide. Sodium carbonate formed is collected, because this is the main aim of this process is formation of sodium carbonate. Therefore, this sodium carbonate here is going to be collected and bagged, and therefore it is stored and transported to, or it's used in formation of glass. Finally, I'm going to explain what happens in this chamber. This chamber is called Ammonia Regeneration chamber. So I will write Ammonia A Regeneration chamber, ARC. What happens during in this chamber is that the calcium hydroxide aqueous obtained in the silica is reacted with ammonium chloride. And I'm going to write the equation. Calcium hydroxide, is reacted with ammonium chloride from the filter. And here, in this equation, because this chamber is called ammonia regeneration, that means we are going to form ammonia in this chamber. And remember, ammonia is required in this chamber, in the ammonation chamber. There is going to be recycling from this chamber. We don't want any waste, so we are going to recycle the ammonia that will be formed here back to chamber number 1, the ammonation chamber. So in this equation, another product, calcium chloride, is formed. Calcium and this chlorine, calcium chloride is formed. Ammonia is formed. Ammonia NH3, which is a gas, is also formed in this reaction. And some molecules of water are also formed. Of course, water is in liquid state. So in this chamber, 3 products are formed: calcium chloride, ammonia gas, and water. Because we don't want any wastes, and in these products formed, ammonia is required in chamber number 1. Ammonia gas is recycled. So I will place an arrow like this, and I'll come here and show that ammonia gas is recycled, and again the process repeats itself to the carbonator, and the process ends in that way. Welcome, thank you for listening, and please subscribe to my channel. Thank you.